Okay, well, there are three problems here. Start with this one because it's the easiest. If you know what to do. Now, let's just think about what you have to do. What's an inverse function? It swaps the x and y. Okay, x becomes y and y becomes x. If you were writing that down, you swap x and y. When you begin the problem, you would not have forgotten what to do between Friday when it was due and today, okay? Or Saturday, I don't know. But many of you did. And many of you who have been doing great work, okay? Just take a lesson. Write things down. It's how you reinforce it, okay? So, write that down every time you do a problem. You're probably not going to forget it anytime soon. So when you have a test later this week, you know what to do. Okay, so you swap x and y. Okay, so x equals 3x plus 7 means y equals 3x plus 7. It's not a great statement, but you can use that. Okay? Or you could say reverse, you know, whatever word makes sense to you. Switch x and y. Lots of different ways to say it. I'll just put 3 dots here. Everybody can solve this for y. You're going to get x times 7 over 3. Check or verify. Well, actually, then verify. F inverse of f of x equals x, because that's what inverse functions do. F of x does something to x, gives you an output. If you apply f inverse to that output, you get x back. It undoes. This function undoes this one. This one operates on x. Whatever it gives you, this one undoes it, so you get x. Okay, so f inverse of f of x equal. Well, here's your formula. It equals f of x minus 7 over 3, which equals okay. That's it. It's just substitution. F inverse of x is x minus 7. So F inverse of f of x, x has been replaced by f of x. That becomes f of x minus 7. There we have it. And then we take the formula for f of x, 3x plus 7, place f of x by its formula, do the arithmetic, fill in the algebra, and you get x. Now you can do the same thing. F of F inverse of X, and that's what it means to verify or to prove that you have an inverse function. Okay. We're not going to give you real complicated functions on the test. I just want to see you know to solve X and Y, solve the equation. Okay. Incidentally, I'm going to digress for just a second, something very interesting. And I'll refer to it again later in the course, probably, because it turned out to be a pretty interesting problem. Okay. F of 4 equals 12 and F of 0 equals 6. That means the point 4, 12, the line on the graph, and the point 0, 6. Here's the point 4, 12. X is 4, Y is 12. Here's the point 0, 6. There's a line through. Looks like I did a good job of that one. Usually miss when I hit them dead center. Okay. And that line's pretty straight too. Whoa. Okay, well, I'm all proud of myself for that, but let's move on. Okay, so what do you have to do to get the equation of the line? You have to get the slope and the y-intercept. Okay. Kind of small, but I think we get through this. M stands for the slope, which is the rise over the run. I will ask you, and in fact, I'm going to kind of require you, when we have a test over this stuff, this won't be on the test. The upcoming test, it'll be on the base. Why are you drawing another triangle that we talked about this? Drawing this triangle. Talk about it in this class. In the rise and the run. Well, the rise is what? Y goes from 6 to 12 here. 12 minus 6 equals 6. And the run goes from here to here. Go from here to here. Now, did we draw the triangle with the arrows and stuff? Did we do that class? If we didn't, then you said more about it. Okay. So anyhow, we use this triangle and we get the run. And that's 4 minus 0. And that's 4. So the slope is 4 and the y-intercept is 6. So we get y equals 3 halves x. And the y-intercept is 6. I gave you the y-intercept. And I gave you the y-intercept here. Okay. Now, a lot of you solved it using the y2 minus y1 over x2 minus x1, which doesn't tell you much. I don't even try to copy this. We'll do another example bigger. And spell it out shortly. And if you use the x2 minus x1, the whole point is f of 4 equals 12, f of 0 equals 6, gives you 2 points on the graph. Okay, and that's the way you can look at it. If you've got 2 points in the graph, you can find the slope. Okay, at least. Maybe you can, maybe the y-intercept is one of your points, maybe not, but you can find it then. Well, I guess maybe the next thing I'll do is I'll do something like that. Okay, so Same one. So one way or another, you got 2 points on the graph. 0, 6, and 4, 12. Well, that means, of course, here's your line x equals 4. Here's your line y equals 6. Here's your line y is 12. Help you see the picture to label these things, just the way you label. Now, camera's out of focus, but it helps to see these things just the way you label them when you're constructing toolkit functions. Okay. Need to understand these things. Okay, and of course, this is a line. X equals 0. This is a line y equals 0. We want to reinforce that because it's important to be able to see that. Plus, open math is going to ask you to graph the function x equals 4 or y equals 7. Okay? And you should know how to do that without even having to look at open math if you label your construction lines. Okay? And understand coordinate plane to the extent that most of you seem to understand it at this point. And the extent that you want to understand it when you take the test. Okay, so anyhow, you got the line. Yeah, I didn't go through the points. I stopped to think about it. That was the end. Okay. But there's a line. Okay. Now, this triangle that I'm talking about, that I call a fundamental triangle. You go from point to point directly, and that's one side of the triangle. That's the hypotenuse. And then you follow a path parallel to the x-axis and then parallel to the y-axis. Goes from this point to this point. Okay? And you go left to right. So this one will always be to the right, it'll always be positive. If this point is lower than this one, then you're going to have an arrow that goes down. Okay? So this arrow doesn't always go up, sometimes it goes down. Okay? Now, how long is this arrow? Well, it goes from x equals 0 to x equals 4. That should be a no-brainer. It's 4 units long, right? But you can calculate it. Call this the run. And it's 4 minus 0. In other words, going from x equals 0 to x equals 4. That means we went plus 4 units, and you get that by subtracting the 0 from the 4. Rise. So you've gone from y equals 6 to y equals 12. You got these lines here. You can see immediately you've gone from y equals 6 to y equals 12. It makes it easier to look at. Right up here. Well, there's rise over run, which is 6 over 4, which is 3 halves, and we label it like this. Put the 3 halves in a box, so we don't think it's the length of a line. Put the box around it, tips us off that that's a slope. So the equation the line is y equals mx plus g. M is a slope. E is the y-intercept. Y equals 3 halves x plus 6. Think about that process. It's serious. It's a lot easier than a lot of the stuff we've been doing, isn't it? Okay, so nail it now, so you don't have to worry about it the night before the test, the next test, not the one we're having this week, the next test, okay? Get or middle end of October, okay? There it is. Now there's more to it, of course. I gave you just 2 points to the line. Of course, there's a formula for it, and people remember those formulas pretty well. But you want to understand it the way I'm going to do it. Okay, so let's try this. Get the equation of a line through, let's say, 2, 5, and if that's 2, that's about 9. About the same. Okay. Now I'm not going to have you do it. I'm going to show you. So you can just go along with it. Okay, so there's the line, sort of. This is what we do. I'll make it a big X so you can tell. Okay, so y equals mx plus b. You got to find them. How are you going to find them? You got to draw this triangle. So this has meaning to you. Okay. And you're going to label it. Run equals, well, you know, don't have too many points. It's really a good idea. Find yourself. I'll put these horizontal and vertical lines to be. So the run is from the x equals 2 line to the y equals 9 line, right? So I go this line, this line. And the run is then 9 minus 2 equals 7. Rise goes from 5 to 11, which is 7 minus 5, which is 6. So the slope is rise divided by run. Now I've written that down. It's just slope equals rise on run. You want to write that out. You want to reinforce what the slope is. You want to do this. It only takes a minute to draw this triangle and label these with everything that you need to have a picture instead of a formula. You've also got the formula. In the formula, it takes the picture. You want both. You won't understand it very as well if you just use the formula or if you just use the picture. What you have broken. Anyhow, rise is 6, run is 7. So it's 6 over 7, and there we have it. I call this a fundamental triangle. And a fundamental triangle always has this label. Okay? It tells you what the slope is. Alternatively, you can use y2 minus y1 over x2 minus x1. y2 is 11, y1 is 5. y2 minus y1 is 11 minus 5, which is 6. That's your numerator. And then x2 minus x1, well, it's going to be 9 minus 2 or 7. So you're going to have 6 over 7. The formula is a good way to get the answer without ever understanding what it means. Okay, you need both the picture and the formula to understand what you're looking at. So try to make sure you have those things. Okay, well, we have it. So y equals 6/7 x plus b. We don't know what b is. Over here, we knew what b was because I gave you the intercept, y-intercept. Well, we can use this point or this point. Okay. Now give me a thumbs up if you want to use this one, thumbs down if you want to use this one. I don't care. Way it goes, it's gonna work. Okay, I get a lot of thumbs down. People want to use this one. That's right, isn't it? Okay. Okay. So we get y equals y equals 5 when x equals 2. That's because 0.25 is on the graph. X is 2, y is 5, right? So we plug in. And we get 5 equals 6/7 of 2 plus b. How do you solve that equation for b? Easiest thing to do is get rid of the fractions. Multiply both sides by 7. Seven multiplies everything. Let's do this 35 equals 12 plus 7b. And with a simple algebra, or a simple arithmetic. And 7 times 6/7, so 7 will divide this 7. Leave you 6 times 2, which is 12. 7 times 5 is 35, and 7 times b is 7b. Couple steps. Did you want to write out to be sure? B is then going to be 23 over 7. If I did my arithmetic correct. So the 6/7. So there's your equation. If you got 2 points, you can always do this. There's also formula y minus y1 equals m times x minus x1. But you want to be able to do this too because you don't have a simple formula for the other types of functions. These are linear functions. If you got a simple formula for it, that's fine. It's a good formula. But don't just rely on it. Be able to construct it. Be able to own it. Okay? You don't own the formulas unless you also own pictures. And once you own it, then you have it. If you ever need it again, simple refresher will do it. Okay. There's high level mathematics I learned over 50 years ago. Haven't looked at it since. Okay. So I'm back to just make a quick refresher and I'm back where it was 50 years ago. A little dumber, but you know, same idea. And I actually understand a lot of things better because I've gained perspective over 50 years. Well, you can do the same thing. If you use the mathematics, if you learn it in a way that you really have it, then your understanding keeps growing. And you can use it in all kinds of ways. Okay, well. Just take a quick look again at your homework to see what else I might need to tell you. Okay, now I'm going to do a piecewise function. This is simpler than the piecewise functions you're going to see on the test, or that you're likely to see on the test. I can't ask you everything, but it's one of the things where you have a piecewise function consisting of toolkit functions. Okay. Oh, this point be -2, 7. This point be 1, 3. This point be 1, 8. Let this point be 6, 5. Right there's a piecewise function. Can you write the formula for that piecewise function? Well, you have 2 points here, right? You have 2 points, so you can find this linear function, can't you? Okay. So I'm not going to take the time to do this. I'm just kind of warning you, there's at least one problem of this nature. Maybe you have more than 2 straight line segments. So, you know, I'd recommend you go, here's X equals 1. Doesn't take long to do this. Clutters up the picture a little bit, but it also illuminates a lot of things to do that. So and get the formula, define each linear function, etc. We'll leave this at etc. because you'll see examples. The key thing you have to focus on is the first thing you want to do. You got 2 points on each of these line segments. You can find the formula, the equation, that function. Once you have those equations, the rest is pretty easy. So you want to just start by and I want to take another piece. Okay. So let's say a rail costs $30 plus $5 an hour. Well, you got the cost, you got the number of hours. Put the hours on this axis, put the cost on this axis. Y is the cost. Call this T instead of X. Okay. An hour. Then, assuming as soon as you pay your $30, you're committed. Okay. If you rent it for 0 hours, it's going to cost you $30. That's like you rent it, you walk out the door, you bring it right back. They could charge you for an hour. So maybe it would be 1 hour, $30. Okay, but let's just assume you're going to get that much compliance on. Okay, so what does the $5 per hour tell you? Well, one thing is, let's say you rent it for 2 hours. How much does it cost? Well, $30 plus $10, right? So one way to put information on a graph that corresponds to this is to say, okay, I would go out here for 2 hours. Here's the line tables. And it's going to cost you $40. You got 2 points in the graph. find the equation in line, right? Just same methods that we've used. Okay, once you practice it, it's very easy. And if you gotta fall back in the formula, well, unless I ask you for the geometry, which I might do, formula is good for you. Okay. What's the slope of this line? Gotta go over it again real quickly, because I got to start recording. You got $30 plus $5 per hour. You can 0.030 because 0 hours costs $30. And to get another point in the graph, so we can draw, so we can write a formula for the function. I just said, well, we know that if you rent for 2 hours, it's going to cost you $10 plus the 30. So 2 hours is going to cost you $40. Then we can do this triangle, and we can work out the rise and the run and the slope. Okay, so this is a large triangle between 0.30 and 2.40. The rise is 10 what? $10. Cost is in dollars. I didn't write that here. I should have said cost in dollars. And the run is from 0 hours to 2 hours. Run is 2 hours. Okay. So the slope is rise divided by run, $10 divided by 2 hours, which is $5 per hour. So I'll put that on my triangle. And I will put in the box my original graph. Okay, well, how do you get the equation? Well, the equation is y equals mx plus b. Got to use c for the cost, t for the time. So instead of y and x, I'm going to use c and t. So I'd write c equals mt plus b. Just replacing y by c, x by t. And give it more meaning. So the cost then is the slope times t. The slope is $5 per hour. Multiply that by 2. And then you add your y-intercept, which is right there. It's 30, meaning $30. So I'm going to put the dollars in. I also said, check that this is homogeneous. That is, that when we multiply these things out and add them, we end up with a real cost. Okay. Well, that means multiply dollars per hour times the time in hours. Dollars per hour multiplied by hours gives us dollars. Right? And this is $30. So this is dollars and this is dollars. This is going to be dollars. We want to check that. If I accidentally had a t squared there, it wouldn't work. Okay. So again, you're going to see problems of this nature, and we'll talk about them more next time. One more thing, and you'll see this. All lines have the same slope. Perpendicular lines have negative reciprocal slopes. For example, you got y equals 4/7 x plus b. Line parallel to this would have the form y equals 4/7 x plus b, because parallel lines have the same slope. If it has any slope other than 4/7 or some equivalent of 4/7, it's not parallel to this one, and the lines won't meet. Line perpendicular to this has the form y equals -7/4 x plus b. Okay. So if you know, if I give you a point, say the point 714, it's not on this line, I don't think, no. Okay. And have y equals 7/4 x plus b, be specific, 7/4 plus whatever, 15. Okay. 15 doesn't matter. For parallel lines, you don't know what b is. You know, the lines here, this line is here, and this line goes through a point up here. It's going to be up here. It's going to have a different y-intercept. Okay. Okay. So anyhow, you know this and you know this. So if you want to find the equation of a line parallel to this, if I give you a point, you're going to have an x and a y. You put the x in here, you put the y of the point in here, and you solve for b, then you have your equation. Okay. If it's perpendicular and I give you a point, you put the x in here and the y in here and find b. It's easy, you just have to know that. I mean, numbers can get messy and everything, but it's not conceptually difficult to do that. So for the exponential function, horizontal lines, you're going to have one. You start at the top, you go halfway to the bottom. Then you go halfway from there, halfway from there. Okay. And halfway from there. Now I'm drawing it pretty small. Otherwise, I'll draw a bigger one. Okay. It looks like this. Now, what I'm saying in a lot of papers looks like this. You see the difference? This is not done by the rules. The rule is you start at the top, go halfway, then go halfway, then go halfway, and then go halfway. Okay? And sometimes you go halfway a few more times, but you can't draw them all. That's coming up. Okay? You have to be able to do this. I said this before. I mean, I've been urging you to do this. So, and it's easy. It's so easy. Everybody, there were twice as many people in here did it right. People bailed from the course for one reason or another. Maybe life's gotten in their way. Maybe they didn't have time to do it. Maybe they just need to stand. I don't know. I got to pose a question. How could you not know this? Okay, with the test coming up, I would have spent time reviewing this weekend to get started instead of the night before, which is too late. Okay, think about it. Okay, well, anyhow, then you draw a line here, the middle, I kind of just did it. And halfway from this edge to the middle, halfway from this edge. If you were doing the scoring function, you would add a couple more lines. You'd have one between here in the middle, one between here in the middle. They wouldn't be equally spaced. You wouldn't get a grid that looks like this. You get this. The scoring function for your grid would be like this. You have to know the rules. They're written out. You should be reviewing the rules, writing out the rules every time you do it. I mean, you just got to say, okay, top halfway to the bottom, iterate. Okay. Each side halfway to the middle, iterate. Iterate means just do the same thing. It's the last line you do. Okay. Now, that should be automatic, and you should be able to sketch for the reciprocal function or the squared function. You have to know that. I'm not going to explain it again. You go back and look at it. I mean, I wouldn't mind explaining it again because I kind of like it. But it's a waste of time. If I explain it again and you're not getting it, it's not going to help. You go back and look at the original explanation. Yep. Want to spend our time on things that are actually going to help. So, okay. So now we want to extend boundary lines. This boundary would be 5, -15. Oh, sorry. I bring some patterns that aren't there, and then I write them down. This is x equals 5, and this is x equals 9. Because it's a 4x4 rectangle. I said it was 4x4. 5 to 9 is 4. Run between these lines is 4, although we're not going to rise and run. Structure. Okay. Then we have y equals what else here? Well, this is -15. This is 4 units higher, so you add 4 to -15, you get -11. So you got negative numbers that are increasing. Even though 11 is less than 15, -11 is greater than -15 because it's closer to 0. Okay. Again, these things you have for them. It should be easy to label the rest of the lines. This is 5, and this distance is 4, and these are all equally spaced because of the rules. You know, you do the middle, then you got 2 here and 2 here. Then you go halfway from here to the middle. You're going to have 1 here and 1, right? Okay. Then you're going to have x equals 6. Of course, you're going to have x equals 7 if you go through this point. So have x equals 8 and x equals 9. And y equals -13. And y equals -14. Y equals -14. Now, y equals -14. Well, you get all that labeled, and you do your exponential. Well, what I'm asking you to do, and I've already asked you to do it a number of times, starting the second week of class, okay? You want to go back and look at those assignments and make sure you know how to do them. What you do is you write out the function out. Okay? So who could function at y equals 2 to the x? Got a horizontal shift of 7. Vertical shift, -15. So y equals f of x minus h plus k. F your f of x is 2 to the x. And that equals what? Well, you replace x with x minus h, you get f of x minus h, you get 2 to the x minus h plus k. That plus -15. So this graph should be y equals 2 to the x minus h is 7, x minus 7 minus 15. You estimate the coordinates of a point. Okay, so I could estimate this point here to be really have room to label this line here. But X looks like this. Okay, between 7 and 8, somewhat closer to 8. So I'm going to estimate that this point is 7.7, and the y coordinate is between -14 and -13, closer to -14, -13.6. Now you take your calculator and you plug in 7.7 per x, and you see if y is equal to -13.6. Then, if you understand this, you verified the whole form of translation and stuff, and you own this stuff. If it doesn't own you, you own it. If your estimates agree reasonably well with the function. If they don't, you need to practice until they do. Okay? And if you do that, you're probably going to have 3 problems on the test that ask you to do this stuff. Okay? In addition to rate of change on an interval and stuff like that, you'll see that when I throw it up on your assignment page. Okay? It'll be a link because it's a long file. I don't want to give lots of examples. Okay, well, good luck. You want to start thinking about the test as well as get that assignment. Don't have time to work on it till this weekend. Okay.